Hello everyone, welcome back to online class. I hope all of you have done exercise 8b and all of you have understood about the multiplication of a scalar with a matrix. Now, today we are going to learn about multiplication of two matrices. Okay, multiplication of two matrices. When we multiply a matrix by a scalar, that is a single number, a real number, we simplify just by multiplying all the matrix terms by that scalar, and we can also multiply a matrix by another matrix. Before this class, we have done the multiplication of a matrix by a scalar, and now we are going to learn about multiplication of matrix by a matrix. Okay, but this process is more complicated, even so it is a very beautiful and interesting. So learn how to do it. In maths, matrix multiplication is a binary operation that produces a matrix from two matrices. For matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix, and the result will have the same number of rows as the first matrix and same number of columns as the second matrix, and every element in a row is added to the multiplication of every element in the column. Okay, so just have a look at here. Multiplication of two matrices. Let us suppose two matrices A equal to A, B, C, D, and the matrix B equal to E, F, G, and H. Okay, both are 2 cross 2 matrix. Okay, then the product will be then the product will be AB, that is A into B, equal to AE plus BG, that is AE plus BG, and CE plus DG, CE plus DG. Okay, first row with second column, second row with second column, then first row with just see the multiplication. First row with first column. This one is our first row, first column, first row and first column, AB and EG. Okay, then after second row with first column, second row with first column. Okay, again just see first row with first column, then second row with first column. Okay, then after first row with second column and second row with second column. Okay, remember it. First row, first column, second row, first column, then after first row, second column, and second row, second column. So this is known as the row by column method. Okay, and we'll discuss it later. Just see this one. This one is the formula you have to remember. This one. Okay, by these two matrices. Okay, so the product AB can be obtained if and only if, that one I have written, if and only if, you can write it like this, the number of columns in matrix A is equal to the number of rows in matrix B. So that is, if A is of order m cross p and B is of order p cross n. Why m cross p and p cross n? Just have a look at here. M cross p. M means the number of rows and n means the number of columns. Okay, and p is here number of rows in matrix B. These two you can see it here. Here this p is in number of columns, but here the p is in number of rows. Okay, then the product of the order will be m cross n. Okay, see here I have written matrix A and matrix B. This one is m cross p. The order here is p cross n. Number of rows, number of columns. Here p is the number of rows and n is the number of columns. Okay, now just see, if A is the order m cross p and B is the order p cross n here, so that the product AB will be, the order of AB will be m cross n. Okay, now just see that rule, how many steps are there to understand this formula. Just see what you have to do. 4 steps are there. That steps you have to remember so that you can solve all the matrix multiplication easily. Okay, just have a look at here. Steps. And I said which method this one? Row by column method. The matrix multiplication, that is an row by column method. Okay, here I have taken matrix A equal to ABCD and matrix B equal to EFGH. Okay, as I said, first row with first column you have to multiply and you have to write. So the corresponding element, that means first element with first element of second matrix and second element of first matrix with second element of second matrix, you have to multiply and that two you have to add. Okay, just remember it and see these steps very carefully from the two matrices. Okay, step 1, AB and EZ. As before I said, first row with first column you have to multiply and you have to add. So A with B, you have to multiply. Okay, the matrix A with matrix B you have to multiply. So what is the first rule? The first step is AB, first row AB and that's what I have written, AB and EZ. And how you have to multiply? First element of first element, second element and second element. Okay, the two you have to multiply and you have to add. So AE plus BG. Okay, then after the second row, with first column, first row with first column, then after second row with first column. Okay, second row it is C and D and first column E and G. So C with E you have to multiply plus D with G. CE plus DG, AE plus BG. Okay, and step 3 is first column with first row with second column and second row with second column. First we have done first row with first column, second row with first column. Okay, so first column is over, so leave it. Now just see, first row with second column and second row with second column you have to multiply, and by adding you have to write the matrix elements of the product. Okay, so step 1 is over, step 2 is over. Now step 3, AB. Step 3, as I said, first row and second column. In first row AB is there and second column FH is there. So AB and FH, A with F and B with H, you have to multiply A plus BH. CD and FH. So with C you have to multiply F and plus D with H. Okay, CF plus DH. That's what the formula I have written here. AE plus BG, CE plus DG, AF plus BH and CF plus DH. AE plus BG, CE plus DG, and this two is over. Now AF plus BH, then after CAF plus DH. Okay, don't get any confusion, just remember all the steps. Okay, these steps you have to remember. Okay, so here let us take one example. The matrix A equal to 1 2 3 4 and matrix B equal to 5 6 7 8. Okay, now the product AB, the rules I have written here and I have multiplied, and by adding I got here 19, here 43, 22 and 50. So 19, 43, 22 and 50. Now one question is there, how you have to place the matrix elements in this product. Okay, how you have to place it. So according to step 1 will be the first element and step 2 will be the second element here, not this one. Okay, this one, and third step will be this one, third element, and step 4 will be this one will be the fourth element. So confusion is there in between this and this. Okay, so remember this one is the row by column method. Okay, row by column method. So that's why according to this you have to write first 19 and this one as 43 here and this one as 22 that is here and this one as 50 that is here. Okay, I hope all of you have understood, or else repeatedly just see this video. Okay, so that you can understand it very well. Okay, now students just see identity element for multiplication. Already we have discussed in previous classes about the unit matrix. Okay, and diagonal matrix and all we have already discussed. The definition of the matrix, identity matrix, is the n cross n matrix denoted by In. N cross n means, n matrix means that obviously that will be a square matrix. Okay, it is denoted by In because identity matrix will be denoted by I. Okay, is a matrix with n rows and n columns. I have written that square matrix. The entries means the matrix elements on the diagonal from the upper left to the bottom right. From the upper left means here it is left to the bottom right. Okay, are all ones and all other entries or matrix elements are 0. Okay, from the right, so left of the bottom, from the left of the bottom to the right of the, from the right, all are will be 1 and rest of the elements will be 0. That is known as the identity matrix and it is denoted by I. So here why I have written I2, because Here this one is a 2 cross 2 matrix, so this one is I2, and here 3 cross 3 matrix, so for that I have written I3. Okay, and how to represent the identity matrix, all of you got it. The product of any square matrix and appropriate identity matrix is always the original matrix. And what you mean by this? Therefore, A times I, okay, A into Y, the product of A means what? A matrix, and I means what? An identity matrix. A into I equal to I into A, that is equal to A, because I means identity matrix, that should be like this one or this one. Okay, and AI2, a 2 cross 2 matrix will be I2 into A, that is equal to A. Whenever you are multiplying a identity matrix with a matrix, you will get the same matrix. Okay, remember it. And while in real numbers also you have learned it, that is 1 is the additive identity, and in multiplication 1 is the multiplicative identity and 0 is the additive identity, because when you are multiplying 1 with any number you are getting the same number, and when you are adding with 0 you will get the same number. So 0 is the additive identity and 1 is the multiplicative identity. Same as like that in matrix also, identity matrix is there. When you will multiply with that you will get the same matrix. Okay students, I hope you all have understood it well. Now in next class we'll read about the properties of multiplication of the matrix. Okay, and that's all for today students, and your homework is just remember all the steps how you have to multiply a matrix with another matrix, and just open your page number chapter 817 exercise 8C and do question number 1. Okay, all the multiplication. Here three matrices are there, A, B and C. A, B and C, three matrices are there. Only you have to multiply, okay, by using the 4 steps which I have said to you. Okay, so that's all for today students. Thank you and take care. Bye.